Hey, welcome back to your favorite intermediate algebra course. We're going to look at addition, subtraction, and complex fractions. So we're going to add and subtract some rational expressions today, as well as simplify some complex fractions. Okay, so let's just remind you this first example here in green, 2/3 minus 7/3. You know, if you're just subtracting some regular old rational numbers here, you want to make sure, do I have the same common denominator? Sure, we do, right? And we went, well, 2 minus 7 all over 3, so negative 5 over 3 was our answer to do that, right? Well, it's the same thing here if you got some rational expressions here. So let's say we got this 11 over 7x minus 4 over 7x. You notice that they both have a common denominator, so we don't have to force a common denominator. So we just go 11 minus 4 all over 7x. So that's 7 over 7x. And you notice that the 7's cancel. Okay, so it leaves you with 1 over 1x, or 1 over x. Okay, let's look at the next one here. Let's do a little more complicated. Let's say that we do not have a common denominator. So what did we do? You know, just with, let's say we just got the numbers 2/3 minus 3/4. You know, what did we do if we were trying to add those? Well, didn't we get a common denominator? So we looked at 3 and 4, and the least common multiple is 12. So we gave this a 4. So we multiplied it by 4 over 4. And then we gave this one a 3, 3 over 3, right? So we had 8/12 minus 9/12. So 8 minus 9, negative 1/12, right? Isn't that how we solved those when we were subtracting rational numbers without common denominators? So let's look it over here. So instead you got this, let me erase this here. X plus 2 all over 3x, and the other one's x over 3x squared plus 9x. So we're adding these again. So if you're adding or subtracting, again, you gotta have a common denominator. So we're gonna force a common denominator. But let's put this in factored form first. So let's factor that 3x squared plus 9x. So you see the 3x squared plus 9x. We'll take a 3x out, and we got x plus 3. Okay, you see how if we distributed that back, that's 3x squared plus 9x, right? Now notice they both have a 3x, don't they? Okay, but this one over here's got an x plus 3. The one on the left side does not. So we got to give it an x plus 3 so that we can get a least common denominator. So you notice now they both have 3x and they both have x plus 3. So we now have forced a common denominator. So let's write it. X plus 3 times x plus 2 all over this 3x times x plus 3. And then we got plus x over this common denominator. Now with that common denominator, I can write it as one rational expression. So x plus 3 times x plus 2 plus this x all over our common denominator. Okay, so now we're just going to FOIL this thing, combine like terms, and let me take this up here. FOIL this thing, combine like terms, and simplify. Okay, so x plus 3 times x plus 2 will give us x squared plus 2x plus 3x plus 6. Still got plus that x all over common denominator, 3x, x plus 3. Okay, combine like terms, so 2x plus 3x plus 1x, that gives us a 6x in the middle here, all over this 3x times x plus 3. And you notice the x squared plus 6x plus 6 does not factor, so nothing will cancel out, you know, going back to last section. So you gotta just circle it right there, you're done. Okay, so x squared plus 6x plus 6 over 3x times x plus 3 with a regular old number. Okay, so let's look at this next one here. 2x over x squared minus 1. I'm not in factored form, so I put it in factored form first. Put this in factored form. Put that one in factored form. Now you can compare denominators. Okay, you notice that they both have an x plus 1, don't they? X plus 1, x plus 1. Perfect. But the left-hand side has an x minus 1, whereas the right-hand side, see that x minus 1 right there? Right-hand side does not, so I give it an x minus 1. Okay? Now the right-hand rational expression here has an x plus 1. whereas the left-hand side does not have a second x plus 1. So I give it an x plus 1 over x plus 1. Okay? So let's write it now. So I have x plus 1 times that 2x, let me put that 2x in front, minus, now this minus right here, this pertains to that entire numerator. Okay, so minus, put that in quantity x plus 2, and you got that x minus 1 now, and this is all over x minus 1, and you got 2 of these x plus 1s now. Okay, that was your common denominator in this case, okay, and then we just start cleaning it up. So clean this up, FOIL that. Okay, so I got 2x squared plus 2x minus, then you do the FOIL. Okay, so you got x squared minus x plus 2x, so that's x squared plus x minus 2 if you were to combine those like terms. This is all over that common denominator. I got x minus 1, and I got 2 of these x plus 1, so I'm going to write that x plus 1 quantity squared. Okay, distribute that minus through. So I got it, 2x squared plus 2x minus x squared minus x plus 2 over that common denominator. 2x squared minus x squared, that's a positive 1x squared. It's like I got a 2x minus x, so that's a plus x, plus 1x. And then I got the old plus 2 on the end. All over x minus 1, x plus 1, quantity squared. Okay? I try and factor the numerator there, that x squared plus x plus 2. It does not factor, so I leave it just like that. Okay? So x squared plus x plus 2 over x minus 1 times the quantity x plus 1, quantity squared. Okay, let's try some 3 more here, kind of some review problems here. So if you want to pause it and try these first, that'd be great. Okay. Right here, you notice that they both have an x plus 5 denominator, so it's common, right? So we just go 1 minus 4, negative 3 all over that common denominator, x plus 5. Okay. This second example in black here, you notice that it's not factored, so we get it factored first before we do anything, before I can even try and get a common denominator. Okay, they both have an x plus 4, so they have that in common. Now you notice the left-hand side has x minus 4, so I got to give this right-hand side, give it an x minus 4. And then the right-hand side has a second x plus 4. You see it right there? So I got to give this one an x plus 4. Okay? So we got 3 x plus 4 plus x times x minus 4, and this is all over x minus 4, x plus 4, x plus 4. That's our common denominator on both of those. Okay. Distribute, combine like terms. So we got 3x plus 12 plus x squared minus 4x all over common denominator, x minus 4, x plus 4, quantity squared. There's 2 of those. Rewrite that. X squared, that's my only x squared right there. 3x minus 4x, so I'm combining that one, 3x minus 4x minus x plus 12, x minus 4, x plus 4, quantity squared. Now this one will factor into x plus 4, x minus 3. I still got x minus 4. I got these 2 x plus 4s if you remember. Okay, so those cancel. So I'm finally left with x minus 3 on the top, x minus 4, x plus 4. Okay, so there it is. All right, let's go over here. So now we got, again, no common denominator, so let's factor it first. Take a 2x out, 2x squared out, I'm sorry, left with x plus 4. Okay. Now you notice this left-hand side has 4x squared, whereas the right-hand side only has a 2x squared. So I'm going to give it 2. Okay, so they both have 4x squared, right? And then the right-hand denominator has an x plus 4. I need to give this an x plus 4. Okay, and this will become x plus 4 times 1 minus the 10x all over 4x squared x plus 4. Okay. Now I can drop those parentheses on that x plus 4. So I get x plus 4 minus 10x over common denominator here. Let me go down a little bit. So x plus 4, whoops, there's an x right there. X minus 10x negative 9x plus 4 all over 4x squared x plus 4. Okay. All right, let's move on here to some simplification of complex fractions. Okay, you notice how we have these complex fractions is simply a fraction that contains a fraction in its numerator or denominator. And in this case, you notice we got this fraction in the numerator. And we actually have a couple different fractions here in the denominator, don't we? So what you want to do here is you want to force it to be one fraction over one fraction. And then we'll do the old keep change flip. Okay? So like right here, I want to get this to be one term. You know, one fraction, if you will. So right there, I'm going to get a common denominator. Okay? Get that to be one fraction. So get a common denominator. Let me erase that for a minute. Okay? So you notice how it's already factored in this denominator. You got the x plus 1 on the left-hand side. You got the x on the right-hand side. So what you're going to do is you're like, well, that has an x plus 1. This side does not have an x plus 1, so I got to give it. And then this right-hand denominator has an x. This one does not, so give it an x. Give it an x, okay? So this becomes, now this numerator fraction stays the same, okay? This becomes 3x from right there minus this part, x plus 1, all over, and now it's my common denominator, x plus 1. Okay, distribute that and simplify. So I got 3x minus x minus 1. Okay, 3x minus x minus 1. So you get the 2x minus 1. Still got this x plus 1. Now you see how you kind of have this fraction over fraction now instead of a fraction over two different fractions being subtracted? So right here, you want to go ahead and do the old keep change flip, right? So in other words, we multiply by this reciprocal. So times x plus 1 over 2x minus 1, okay? So now right here, what does this become? Notice an x plus 1 here, x plus 1 there, right? So now in the numerator you just have 3x left. This is just going back to last section. And the denominator you just got that 2x minus 1. So 3x over 2x minus 1. Alright? Let's try one more of these complex fraction simplifications here. Alright, so right here. So you notice you want to get that denominator to be one fraction, don't you? Okay, because in this case you have two fractions in your denominator. So the left-hand side has an x. The right-hand side does not. So let's force this to have an x. Give it an x, top and bottom, right? The right-hand side has a 3x plus 1. This side does not, so give it a 3x plus 1, 3x plus 1, okay? So this becomes, the numerator stays the same for now, x minus 2 over 3x plus 1 all over 3x plus 1 times 1, so that part, minus the 2x all over this common denominator x, 3x plus 1. Okay, combine those. So this becomes 3x minus 2x is an x, got the plus 1, and we got over this common denominator there. Alright, now we're at the point where we can go ahead and multiply by the reciprocal, and that'll help us out. Okay. Alright, let's see here what cancels. So I'm looking up here, and I got the 3x plus 1 will cancel with that 3x plus 1, and that's it. So I got x minus 2, and I got an x plus 1 on the bottom. There's our answer. Okay, thanks for listening, you guys. See you in class. Bring your questions.